Hello my dear friends, welcome back to my channel, and in this video we will discuss about one of the basic law in electrical engineering, that is Kirchhoff's laws. And Gustav Kirchhoff is one of the famous German scientists, and he developed two laws regarding with current and voltage, and he deals with the interconnection of number of circuit elements. And the first law that deals with the flow of current, that is Kirchhoff's first law, and that law is also known as junction rule. And the second law deals with voltage drop in a closed network, and popularly that law is known as Kirchhoff's second law or Kirchhoff's voltage law or loop rule. But in this lecture we will discuss about Kirchhoff's first law, that is KCL or Kirchhoff's current law or junction rule, and we can discuss about the second rule in the next video. Okay, so Kirchhoff's first law is nothing but the algebraic sum of current at any junction or node is 0. Node is nothing but a junction of two or more branches of electrical network. Here you can see it is a node or a junction, and the algebraic sum of current at this junction will be 0. You can see here the incoming current to this junction is I1 is one of the current and I2 is there. I1 and I2 are the incoming currents to this junction, and the outgoing current or the current which is leaving from this junction is I3, I4 and I5. So Kirchhoff says that algebraic sum of current at any junction is 0. That means the incoming current is equal to outgoing currents. Normally the direction of incoming current to a node is considered as positive, and the direction of outgoing current is taken as negative. So here you can see I1 plus I2. I1 plus I2 will be equal to I3 plus I4 plus I5. I1, I2 are the incoming currents. I3, I4, I5 are the outgoing currents at this junction. So the net current at this junction will be 0. That is written here. Okay. And based on this concepts, we can solve some problems related with the Kirchhoff's first law. Here, find the value of I, current. Here you can see a junction, and some currents are entering to this junction and some are leaving from this junction. And we need to find the unknown current, that is I here. This I is leaving from this junction. So we can write it here. The incoming current is equal to outgoing current. So incoming current to this junction is 0.2 ampere plus 0.6 ampere plus 0.7 ampere. Okay, 6.2 plus 0.6 plus 0.7 is equal to leaving currents, that is 0.4 ampere, 0.5 ampere and the unknown current I. So by calculating this we can solve I is equal to 2 plus 0.2 plus 0.6 plus 0.7 minus 0.4 plus 0.5. So finally we will get 0.6 ampere is the unknown current which is leaving from this junction. If we put the value of 0.06 ampere to this point, then we will get the net current at this node or junction will be 0. Here you can see another problem. A current of 0.5 ampere is flowing through the resistance of 10 ohm and find the potential difference between its ends. Okay, so here we need to find the potential difference, that is voltage. We need to find the voltage, and the given quantities in this problem are 0.5 ampere is the current which is flowing through the resistance, and the value of that particular resistance is 10 ohms. So the given quantities in this problem are current is 0.5 ampere and the resistance is 10 ohm. So by this rule we can say Ohm's law, V is equal to I into R. So by putting the value of current and given resistance, we will get the voltage as 5 volt. Ohm's law is interconnected or basically related with the Kirchhoff's laws. So I put this problem here. Here you can see another problem. Calculate the current and resistance of a 100 watt 200 volt electric bulb. So in this problem we need to find the current and resistance of this given electric bulb or this given circuit. Okay, so the given quantities in this problem are power is given as 100 watt and voltage is 200 volt, but we know that we have a relation of power that deals with voltage and current. So P is equal to V into I. From here we can write the equation for current as P divided by V. So P is given as 100 watt and voltage is 200. By dividing this power with this voltage, we will get 0.5 ampere as the current that is flowing through this electric bulb. And the next part of this question is we need to find the resistance. So from Ohm's law we can write R is equal to V divided by I. So V is 200 and I is 0.5. So R is equal to 200 divided by 0.5. Then we will get 400 ohm as the value of resistance in this particular circuit. Okay. And here is another problem. You can see in the figure given below. Here we can see 2 ohm, 3 ohm, 5 ohm resistors are connected in series with 20 volt DC supply. Okay, so we need to calculate the equivalent resistance of the circuit and the total current of the circuit, the voltage drop across each resistor and power dissipated in each resistor. Okay, we know that in series circuit the net resistance when they are connected in series will be the sum of individual resistors. So here total resistance will be equal to 2 ohm plus 3 ohm plus 5 ohm. We will get the value as 10 ohm and voltage is given as 20 volt DC. So by using these values resistance and voltage we can calculate the total current. We know that for a series circuit current will be same, right? So that current is equal to V divided by R. So 20 divided by 10 we will get 2 ampere and 2 ampere current will flows through this region, 2 ohm resistor, 3 ohm resistor and 5 ohm resistor. Okay, so the value of current is 2 ampere. So resistance already we found it and current also. And third we need to find the voltage drop across each resistor. Okay, across 2 ohm resistor, 3 ohm resistor and 5 ohm resistor. So first we can calculate the voltage drop across this 2 ohm resistor. That can be V1, which is equal to I into, because I is common for these three resistors. So I into the resistance of that particular circuit or the particular resistor, that is R1 as 2 ohm, So current is 2 ampere, so 2 into 2, 4 volt. 4 volt is the voltage drop across this 2 ohm resistor. Okay. And next voltage drop across 3 ohm resistor, that is equal to the current I into resistance of that circuit R2. So current is 2 ampere, 2 into value of R2 is 3 ohm. So we will get the voltage drop across 3 ohm resistor as 6 volt. Similarly, we can find out the voltage drop across 5 ohm resistor I into 5, that is 2 into 5, 10 volt. These are the values of voltage drop across the three resistors. And last question, we need to find the power dissipated in each resistor. First, we can calculate the power dissipated in 2 ohm resistor, that is P1 is equal to V1 into I. V1 already we found it as 4 volt, and 4 volt into current through the junction, through that circuit, that is 2. So 4 into 2, that is 8 watt is the power dissipated in 2 ohm resistor. Similarly, power dissipated in 3 ohm resistor will be P2 will be equal to V2 into I. This V2 is 6 volt into current is 2, so 12 volt as the power dissipated in 3 ohm resistor. And we will get the power dissipated in 5 ohm resistor will be P3 is equal to V3 into I. So the voltage drop across the 5 ohm resistor is 10 volt, and the current flowing through that resistor is 2. So we will get the power in 5 ohm resistor will be 20 watts. So in this way we can calculate, or we can solve this kinds of problems. Okay, in the next video we will deal with Kirchhoff's second law or Kirchhoff's voltage law, and we will solve some problems related with the second law. Okay. Thank you.